Hello all and welcome back. So in this video we are going to continue our discussion on recursion and string and solve one more question. So the question which we are going to solve in this video is palindrome. So our aim is that given a string we have to tell if that particular string is a palindrome or not. So let's get started and solve this. Now for people who are unaware what palindrome is, let me give you an example. This name Nitin is actually an example of a palindrome. The reason for this, no matter if you start from left or you start from right, if you will read it out, it is going to be the same from both the sides, right? Another example for that can be Malayalam. So again with this, from both the direction, it is exactly the same, right? So these are the examples of palindrome. An example which is not a palindrome, of course, ABC. Okay, it's of course not a palindrome. So let us now try to solve this question, everyone. We must have done this similar question using iteration, and in Python, because of the powerful slicing concept, it is very easy, but we have to still make sure that we solve this using simple recursion code and not use the inbuilt functionality of Python. Okay, so let's get started, everyone. First, let us try to understand and think of problem. What I can think of if I'm given a problem, given this particular problem, what I can do from my end is to check the starting and the last character, right? If they are equal, then maybe I can ask recursion to check for remaining characters somehow. Okay, but first I should check, okay, if this is equal or not. For example, in this particular ABC, A and C are not equal altogether, right? So they are not equal. Now we have already seen that we can actually have this start and end pointer here, right? So something similarly I want to use here. And this is the reason I've selected this particular question, so that you get accustomed to using start and end pointer in string as well. Okay, let me write the recursive relation as well for all of you. Recursive relation is something which we can also write here. Now I am assuming that you are actually writing all the recursive relation for all the question which I am doing. So let's say if I am given a particular string s, then what I have to do to write the recurrence relation, s of 0 equals s of length of s minus 1, the last and the first character, and so and or multiply palindrome, and I have to somehow just make sure that I'm able to get this particular part of my string, right? So via indexing that can be easily done. That is something done like this. So it can be length minus 1. This is how we do it via indexing, everyone, right? So I can show you an example as well. Just let me show you an example here. So let's say if my s is equals to Nitin, length of s is going to be 5. Length of s is going to be 5. Let me take it in n. What I'm saying is, if I print s of 1 to n minus 1, then I will remove the first and the last character, right? Yeah. So see, I'm getting ITI. The first character is removed and the last character is removed. Now this is very properly explained in the slicing concept, that how we can do the same. So I'm just using this particular concept. We can do one more thing as well. Now this I'm discussing in depth because this is something which we are going to use in lots of your string question. So we can have a end and start, which can be length of s minus 1, okay, or n minus 1, and I can create my function where I am now, after comparing I'm using the same string, but I'm gonna send s plus 1 and e minus 1. So start plus 1 and n minus 1. So what exactly is happening in this particular case, everyone? I am saying that if Nitin is my string, I'm gonna take my start equal to this. Let me use another pen. Yeah, I'm gonna take my start equal to this and end equal to this. Now in the next call, I'm just gonna increase these pointers. So my start is gonna become this and end is gonna become this, right? Something which we have already used, but I want to still make sure that you can imagine that how it is so powerful in string as well. Okay, so let me remove everything now and let us try to solve this question. I'm just gonna make a function palindrome. Okay, it's gonna get a string s1, and it should just return if it is a palindrome or not. So it's going to return true or false. Okay, and let us pass Nitin only as an example. Now pay attention everyone, that what exactly is going to happen here. Now I can create a helper function here. So just so you remember this as well, I am creating a helper function. So I can just do this length of s1 minus 1. Now this palindrome helper is where I'm going to get my answer. So def palindrome helper s1 start and end, right? Now if the very first is the base case, if start is greater than equal to end, okay, that means that my string is actually having the length equal to 1 or 0, so I can return true. Now this actually is our base case, so maybe let me discuss this as well with you all, what exactly is going to be our base case and everything. Okay, first let us see what the base case is going to be. Now the base case is actually going to be the same only if my length of string is equals to 0 or 1, because a single character is a palindrome and similarly a string with no character is also a palindrome, so I can return true. Second we discussed can be the recursive call. Now for the recursive call we have seen both the ways. We can either slice our string or we can just use the start and end character. Slicing creates a new string in the memory. Start and end we are referring to the same string altogether. Okay, so here we are just gonna do s1, which is the string, start plus 1 and end minus 1. Just one more thing, if we are talking in terms of start and end, then if start is greater than or equal to end, then we say this is the base case. Okay, because let's say if it is NITIN, if both S and E are here, that means start is equals to end. Okay, but if start is ahead of my end, then we have actually messed up something, because that's kind of a negative length string or a zero length string. Okay, so we are saying that yes, we have transferred the whole string. This thing would have been a lot clearer because we have done binary search and everything as well, right? But yeah, I want to just make sure that you understand and are able to visualize how these concepts are interdependent on each other. So you clear this concept one properly, it is going to use everywhere. Okay, so this is how I'm going to do the recursive call. And third can be our work, which is just checking if s1 of start equals to s1 of end, right? Now of course these are something which can be interchanged, so we in this particular code are gonna do our work first. Okay, so pay attention everyone. If s1 of start is equals to s1 of end, or let me make not equal to, right, then we can return false directly, because we don't need to check afterwards, right? If the first one is not character, if this would have been nitim, okay, then of course this n and this m is not equal to each other, and hence I can comfortably say that the string as a whole will not be palindrome. I don't need to even wait for recursion, right? If that's the case, if that's not the case, if they are equal, then the answer will depend on recursion answer, and I can just return whatever recursion says to me. Okay everyone, so yeah, I hope with that it is clear, and the answer is true. Let us check for Malayalam. The answer is true. Let us check for ABCD or ABCDA. The answer is false, right? So I hope this code is clear. Now I am making sure that I'm explaining you pretty easily and by going step by step. The reason is that once your understanding on these basics questions are clear, you will be able to code the difficult or medium questions a lot more easily. Okay, so let me just run this once for Nitin. Let me just show you the function calls for Nitin as well meanwhile. Okay, so what exactly is going to happen? We are going to call with Nitin here. Okay, and this is going to be 0. This is going to be 4. Okay, because Nitin, this is 0, 1, 2, 3, 4, right? In the very first case, this is my start and this is my end, and I see that they are equal, okay. From a code perspective, your work is done here. You can just now let recursion handle the same. Okay, you don't need to draw this, and that is something which I have been repeating so many times. But to understand the same, for understanding perspective, let us draw this. So we are going to get this particular thing in the starting function. Then next, going forward, I am going to get my start and end as 1 and 1 second. Let me use different color, 1 and 3. Now 1 and 3 are also equal, so I'm going to make the call again. This time both my start and end are equal to 2. And if you will see, this is actually my base case, right? If start is equals to end, then this is the base case, everyone. And because this is the base case, I'm going to return true from here. Now we have already checked for our work we have already done. So whatever is getting returned, just as happened in tail recursion, I'm going to return my answer as true everywhere. Okay. So yeah, I hope that helps you to understand it properly, everyone. This is how the flow is going. Now, okay, I mistakenly typed it R, but we can see the same. Now it's false. Okay. You could have done by making the palindrome helper call first as well. I've shown you a lot of times that, okay, this is interchangeable. But I hope in this problem you can understand that why doing R work first is helpful and normally faster. Okay. So yeah, I hope with that this question is clear. Just a request, please make sure that you are running this question on Python tutor once or try to draw this particular tree once. Okay. Moving forward, we are going to do some medium to hard level questions, which are going to actually now test your skills of everything which we have done in recursion. So yeah, please make sure that you have done all the assignments and you do these questions the way I'm asking you, and everything recursion is going to be a breeze for you. Okay, cool everyone. So let's meet in the next class. Thank you.